How can we make a forecast when we have horizontal data? In horizontal data, the sales are not going up or going down. They stay at a constant level with some daily fluctuations. So let's say this is your current time period. And what's our forecast for the next time period? Since we know the sales are constant at this level, our best guess for the next time period is this constant level. So how can we find this constant level using our dataset? Remember, our dataset has daily fluctuations, so how can we get rid of these daily fluctuations? How about if we average them? We'll collect some recent data points and average them. And this is called the moving average method. So how many data points should we average? The number of data points we average is called the order of the moving average method. We denote this by n. And so the forecast for the next time period is the average of n most recent observations in the moving average method. For example, if n equals 3, then we're going to collect the 3 most recent observations and average them. And that's our forecast for the next time period. So in other words, we collect the sales data point from today, yesterday, and the day day before yesterday, and average them. And that's our forecast for tomorrow. Let's take another example. Let's say n equals 5. Then we start from today, go backwards in time until we collect 5 data points and average them. And that's our forecast for tomorrow. You may ask the following question. We know how to make a forecast for tomorrow, but how can you make a forecast for the day after tomorrow? The answer is the forecast for the day after tomorrow is the same as the forecast for tomorrow because we know the data set is horizontal, the sales are not changing. In other words, the forecast for any future time period is the same as the forecast for tomorrow. So let's take an example. Compute a 3-week moving average forecast for the arrival of medical clinical patients in week 4. The number of arrivals for the past 3 weeks were as follows. In the first week, we had 400 patients. In the second week, 380. In the third week, 411. Currently, we are at the end of week 3, and we want to make a forecast for week 4. The question says we need to use a 3-week moving average. That means you need to collect 3 most recent observations and average them. So let's start from the current period, and go backwards in time, and collect 3 observations and average them. So it's 411 plus 380 plus 400 divided by 3, that's equal to 397. That's our forecast for week 4. Now time has passed and we are at the end of week 4. And we know how many patients actually arrived in week 4. We had 415 patients in week 4. Now, what's our forecast for week 5? Again, we need to collect 3 most recent observations and average them. So what are the 3 most recent observations? This one, 415, 411, and 380. And average them. Divide by 3, and that's equal to 402. That's our forecast for week 5. Now let's move on to the exponential smoothing method. This is another method we can use for horizontal data. The exponential smoothing method uses the following equation to compute the forecast. The forecast for the next time period is alpha, which is a constant called the smoothing parameter, times the demand in the current period plus 1 minus alpha times the forecast for the current period. And this was calculated from the previous period. And this requires only 3 items of data: demand in the current period, forecast for the current period, and the smoothing parameter, which is a given number between 0 and 1. Let's look at some example. Consider the patient arrival data given in the table below. It's now the end of week 3, and the actual number of arrivals is known to be 411. Using alpha equal to 0.1, calculate the exponential smoothing forecast for week 4. Assume that the forecast for week 3 made at the end of week 2 is 390. So this is our forecast for week 3, and this was made in the previous period. Now let's use our formula for the exponential smoothing method. The formula is alpha times the current demand plus 1 minus alpha times our forecast for the current period. So alpha is 0.1. The actual demand in the current period is 411 plus 1 minus alpha quantity times the forecast for the current period, 390. So if you compute this, you get 392.1. Now time has passed, and we are at the end of week 4. So we know how many patients actually arrived. We had 415 patients in week 4. Now, what's our forecast for week 5? Again, we're going to use the exponential smoothing method. The formula is alpha times the current demand plus 1 minus alpha times our forecast. So alpha was 0.1. The actual demand in the current period of time is 415 plus 1 minus alpha times the forecast for the current period is 392.1. So this equals 394.4. This is how to make a forecast using the exponential smoothing method.